afternoon. We are live. Excellent. Good afternoon and welcome to this Thursday stream. And today's topic, it's gonna be AWS Serverless Application Model, or SAM. My name is Darko. I am a developer advocate. I work with AWS, and today I've decided to kind of have a look into AWS Serverless Application Model, or SAM. And the goal of today is to kind of let's try to write an application with SAM, or create a serverless application with SAM, and just see how it works. How can we do some local testing? How can we, well, utilize SAM to properly deploy a serverless application? So yeah, that's kind of the goal for the next hour or so. So what is SAM? SAM is an open source framework for building serverless applications. So in essence, it's a kind of a shorthand syntax, or it's a transformation for CloudFormation, AWS CloudFormation, it gives you, those transformations give you a simpler way to create serverless applications within AWS with a CloudFormation-like syntax. So it's pretty neat. If you ever had to create serverless functions before in pure CloudFormation, so in vanilla CloudFormation, you would have noticed that it takes a bit more effort to do so. And with SAM, you kind of have, it's easier to define your serverless application within that template. It's more logical, if that makes sense. SAM also comes with SAM CLI, which is a command line utility that allows you to, well, first of all, it allows you to build and deploy those SAM applications, but it also allows you to actually test those things. So by the usage of Docker, it's able to locally run your Lambda function. So in essence, it's able to like emulate API gateways and Lambda functions locally, so you can do some local development on them. And the goal of today is for me to actually do something like that. So let me actually switch to this. Excellent. So most of today we're gonna spend in the text editor, or in this case, we're gonna spend it in Vim. Let me just zoom in a bit. So where do we start? So I wanted to create a simple application that's gonna create an entry in a Dynamodb table that I can create an entry, read an entry, update and delete, right? So a CRUD application, C-R-U-D. So yeah, let's get started. Similar as with CloudFormation, you start by defining a template, right? A template is written in YAML. I believe you can do it in JSON as well. I'm not sure. To be fair, I don't know. Can you do it in JSON? Doesn't matter. I'll stick to YAML anyway. So we're gonna make this template in YAML, and like with CloudFormation, we're gonna keep a similar form of it as well. So let's get started. Let me create a directory first. Let's call it a stream serverless SAM. Okay, cool. So the first thing we have to do here is we have to create template.yaml. Cool. So in this template, we're going to be creating all the things we need. I'm actually going to start, I'm going to go the proper way. I'm going to use parameters. I'm going to use all the things. Now I have some of this code already prepared, so just so you don't have to look at me type all day, but I'm going to try to be at least entertaining while I do so. So first things first, the basics, AWS template format version. We need to define the template format version here, and it's going to be 2010 0909, the standard one. 0909. So now this is where SAM comes in. So transform. So in essence, SAM is a transformation, or a transformation for CloudFormation. So by adding this, AWS : serverless : and then the sorry, not : serverless, and then this, and then 2016 1031. By adding this, we have in essence enabled SAM. So this template will be using this serverless transform, and we're able to use some of the serverless resources which are available here. Let's make a description. I am using a different keyboard. Let's say CRUD application. That's serverless application. That should be fine. And then let's kick it off with parameters, right? So I have already have this laid out in my head because I want to do some advanced local testing. I want to make sure I can handle it with parameters. So first thing, because I'm going to be using Dynamodb and I need this specific thing for local testing, I want to define a parameter called table name. Table name. And it's going to be a type string, and the default will be I'm going to call my table resource table, like so, right? And I'm going to also create a couple of other parameters as well. So I need table name, I need region name, I need environment name. So let me do this region like so, and let's call it West 1. And then environment name, AWS and name, like that. Cool. So I'm going to be using this to define which environment I'm using. Is it running locally or is it running in the cloud? And this is very important because when we're going to be doing Dynamodb, we want to make sure that we are potentially using the right Dynamodb, and it will make sense later on as I go along. AWS SAM local. So the default one will be local, right? So let's move on to the main part. The main part is, of course, resources, right? Resources. So unlike standard CloudFormation, we do not have to necessarily define a Lambda function here per se, or define a Lambda thing. So we're going to actually create a function, but we're going to call it a serverless function. So you'll see the type is a bit different. So as I said, I want a serverless application that has a get, well, actually create, a get, and a delete option. So basically all the CRUD stuff. So let's do the get one. So let's call it get function. And I'm going to be calling it, so now this is where the serverless or SAM comes in. So type AWS serverless function. Right? It's different. If you would do this in vanilla CloudFormation, you would have to do AWS Lambda function. So there are some differences here. Properties. Handler index.get. And so what this means, it means it will find the index file, or index.js file in this case, because I'm going to be using the Node.js runtime. It's going to be using index, and it's going to use the get export handler, or get the exported get handler, and you'll see that later on once we come to the Lambda function itself, to the JavaScript function itself. So runtime, right? Runtime is going to be Node.js 12x. Code URI. So this is where we actually define where our code is. I'm going to be placing the code in a source directory within the current directory as well. Now, this is also one of the parts of serverless policies. This is where I define what permissions does my Lambda function have. So I'm gonna, because this is a get function, there's a predefined policy available for Dynamodb, and it's called Dynamodb read policy, like that. And I want to say you need to do it for table name, and I'm gonna ref what is a table name. So it's gonna give the read policy. It's gonna give the read permission to my I'm going to give my Lambda function read permission to this Dynamodb table. Excellent. I also want to define some environment variables. So if I do environment like so, and I do variables table underscore name, I'm going to ref table name. So we're going to pass these things on to my Lambda function as we build it. Region. So ref region So I'm basically using the parameters stated up. And the final one is going to use AWS env. It's going to be ref. What is it? AWS env. Excellent. And that's, oh, well, actually, no. Because this is, again, serverless, we can bake in events. So we can add the API gateway directly to this function. So we do that actually with the following. So we create the events property. So events, like so. I'll actually zoom in a bit more so it's visible. Events, and then call it get resource, right? And this is going to be type, is going to be an API event. So it's basically going to be using API gateway and properties. I'm going to just set path, resources, and I'm going to do resource ID. So, and method here is going to be method like that. It's going to be get. So in this couple of lines of code, we have actually defined our Lambda function. So we're saying, hey, it's a Lambda function called get function. We're going to be using the get export handler from the index.js file located in the source directory. We have given it a policy that allows reading of a DynamoDB table with the following name called table name, which is coming from a parameter. And we have also set the environment variables called table name, region, and AWS env from parameters. Lastly, we have created basically integration with API gateway. So by adding events get resources type API, we have created a integration, a method basically, and a resource within API gateway that will handle this function. So in essence, it's going to create an API gateway as well. Cool. So that's one function. Now to make this easier on myself, I can do this, that, paste, paste. Well, that's excellent. We have 3 functions now. Let's call this one put function, right? It's going to be index.put. Now, the read policy will not be enough. So instead of DynamoDB read, I need to do DynamoDB CRUD. Is that the correct one? Yes. So the CRUD policy is basically create, read, update, delete. So in essence, this function has the ability to create, read, update, and delete. It's basically has a read-write proper permissions on top of this table. So instead of get resource, I am gonna be using is this the correct one? Give me just a moment. It's actually this one. Moving it here. Not my Twitter. I need to see this. Yes. So this is a mistake I've made. So it's not get resource. It's no. It is get resource, but in this case it's put resource. There we go. Resources put, and then like so. I'm gonna be using the same thing. It's also the same path. The only thing, the method is gonna be put, as the name says, right? Excellent. So the get function, put function, and let's just move on to the delete function. AWS delete function. Now it's gonna also be the index.delete here, right? Everything is the same. I'm gonna just modify this thing to use CRUD. The same thing, get events. Now it's not get resource, it's delete resource, and then it's gonna be using the delete method, right? Yes. All the same thing, delete. Excellent. Cool. So we have created currently 3 functions, three serverless functions, and have integrated them onto API gateways. So in essence, if I would be creating this right now, it would create 3 Lambda functions and integrate them wholly into an API gateway. So That looks pretty good. Okay, finally, or last but not least, let's actually create a resource table. So let's call it resource table, like so. So I'm going to create a Dynamodb table. So this is not serverless. It doesn't require serverless for you to do this, but I'm going to be using vanilla CloudFormation in this case. AWS Dynamodb table and properties. Such table name. Right, so is it that the name? Yeah. Or AF table name. Attribute definitions. So I'm defining some attributes for my Dynamodb table, such as what attributes I'm going to be using. So for example, attribute name is going to be ID, and the attribute type is going to be a string. I'm going to put an S here. Then define the key schema like that. Attribute name, again ID, and then key type is going to be hash. And then just the provision throughput. It's fine. Read capacity units, it's going to be 1, and then base like that. No, right, capacity units is also going to be 1. Excellent. Now just to kind of make this really nice and usable, let's do outputs. Outputs will be API URL. I'm gonna do that, and description. No, not description. I just do value. Value. I'm gonna sub. I need to modify something. So this is just gonna be an output of CloudFormation. It's gonna output me the actual URL I can use later on. So it's gonna be HTTPS column. Then I'll do like this. Serverless REST API. Execute API dot then the region AWS. So AWS region. Amazon AWS.com/prod/resource. Excellent. So this should hopefully now spit out the API URL after it's finished. So in essence, what we have done here right now, we have modeled our application that currently contains just a single Dynamodb table. It contains 3 functions, and it's all going through an API gateway in this case. So what we need to do now is actually create the Lambda function. Now, and for this, I'm actually not going to do all the typing. I wanted to do the typing here so you can see actually what part of SAM is what doing what. So uncather src, and then let's edit src index JS. So I'm gonna actually paste this thing here now, and like so. Here, insert bam. So this function, I'll explain later on once we get to the testing part, but it just does that. It takes the parameter. If it's the, you can see we have the get export here, the get handler. The get handler basically takes the ID you pass it, or it's the first element of the path, and it looks for that element in a Dynamodb table and returns what it is value, or its body. Then the put one down here on line 40, it's exactly the same, but instead of reading, it takes the body and writes it to an ID key of the path, or the resource ID we defined it. Excellent. So I need a few more things. Edit okay, JSON. Oh, actually, src package JSON. Package. So I need a package JSON file just so I can make it run locally. So the package JSON is just telling it, hey, this is my application. It's called CRUD app. The main one is index.js, and I'm just saying, hey, the dependency is AWS SDK. So this gives us the ability to use Node to build our application, or sorry, SAM to build our application. Excellent. I think this is fine now. we also need something. So if we do, I think nvm use 12. So nvm is node virtual machine. I'm just telling my current session, hey, use nvm node 12. If I do sam build, will this work? It doesn't work. What did I do wrong? So invalid resource, not defined, AWS serverless function. Property environment, not defined for resource, serverless function. So let's have a look at my code. I have made a boo-boo somewhere. Okay, get, that looks fine, environment. Property environment, not defined, serverless function. Is it not? Aha, environment. Okay, sorry. Typo. Excellent. Okay, let me clear this and on this again. Okay, it's building now, so it's actually building my SAM application. So it's gonna be packaging a lot of different things. So if you look at into the, if we do ll AWS SAM and build, we will see that we have 3 independent functions here and the template, and it basically created all of the things for us. So if we would go to like vim AWS SAM build and template, yeah, you can see that it basically has all the same things here. So it's our build serverless application. The only thing it has, the delete, get, and put functions are kind of formatted. Excellent. So now, one of the things we can try is we can try to do some local testing. So how do we do that? Well, SAM supports local testing. So if I can do basically SAM local invoke get function. So I can basically do this. And if I would do this, it will actually run a Lambda function within the container locally on my laptop. And see, it will fail because it's undefined or unexported. Index get is undefined, underexported, blah blah blah. Is it? So we need to complete our example for this sample to work. So let's actually get on it. And now, one of the things I was thinking of when I do my testing is I can easily emulate Lambda functions. As you see here, it tried to execute it, but it failed. So I can also emulate API gateways, but it's not built in to emulate Docker. Sorry, not Docker. Dynamodb. So one of the things I can use, I can actually use Docker to emulate Dynamodb, which is pretty cool. So I am going to be using a Docker image available from, well, Docker Hub to basically run Docker, the Dynamodb locally. So if you see this command, Docker run and then port Amazon/Dynamodb local. So if I do this, it will pull down, if you haven't done this before, it will pull down the image for Docker, and now I have Dynamodb or Dynamodb API endpoint running locally on my workstation. And if I would do something like, let me actually increase this a bit. If I would do AWS Dynamodb list tables and define, not this one, but actually define the endpoint URL, which will be localhost 8000, it will actually make an API call against local Dynamodb, right? So I have a Dynamodb running locally, and it actually made a call against that. Pretty cool. So one of the things I have to do if I want to test this locally, I actually have to create a table locally. So to do that, I've actually have a JSON file here that will help me do that. So, you know, with AWS CLI, you can kind of define, we can kind of define your command in a JSON file. So what I'm going to do here is mkdir.json, like so, and then edit JSON, and I'm going to call it create table JSON. So I'm going to paste this. So this is just JSON document that says, it's basically an instruction to my CLI on how to create my Dynamodb table. And when it does, it's going to create my Dynamodb table locally. So to do this, I can just do AWS Dynamodb create table, table, that's our CLI input. So input JSON, and then point it to a file, JSON, and then I can do create, what is the file name, create table, JSON, create table.json, and then endpoint URL HTTP localhost 8000. So hopefully input JSON. Did I not do something? File. This? No. I've ran this before, so let me just see what is the actual command. Okay, so create table JSON. Oh, it's not this one. Let's see. This should be the one, yeah, create table. That. Why not? Ah, I have not written the file. There we go. Excellent. So it has created a Dynamodb table. See, this ARN is weird because it has all the zeros because it's running locally on my laptop. So if I would run the command which I ran previously, the Dynamodb list tables, it will show me that I have a table called resource table. So pretty cool. Excellent. So now I can now start working with this table, and this is also what I need to do. So to run this locally, I also need to play around with some more JSON. So edit JSON, and I call env.json. So here are the environment variables I'm passing to each of my functions when I run them. So I'm passing the table name, the region name, the AWS environment name, put function, pozdrav, putting the table name, region name, all the things. I'm passing all of these things to my functions so they can basically use them as they run. So once I save this, I should be able to run some local Lambda. How to do this now? Let's see. We have our environment files, we have our templates, and just do SAM build again. I think this should be working now. Build has failed. NVM use 12. I always struggle with NVM. I should have used Python or something. Might have been easier. Okay, cool. So if I do SAM local, then there is this one. Start API. So if I do SAM local start API and pass it on environment variables, it's gonna basically start a local API gateway, and it's gonna be able to invoke our Lambda functions through just the local host, right? So if I do this, excellent. So it's we have an API gateway running on localhost 3000. So to properly test this, I'm actually going to open up Postman. This is horrible. Okay, I can zoom. Nice. So I'm actually going to do something like this. So Postman is a tool that helps you work with APIs. It just gives you the ability to just run basically requests to APIs in a bit more simple way. I could use curl for this, but this is kind of simpler. Right? So HTTP localhost 3000 and then resource. Right, if I do get and ask for a resource named Darko, execute this, I will get a missing authentication token. What did I do wrong? Resources? Resources. Awesome. So do this. It's sending a request. Internal server error. Okay, so what did it fail? Index get is undefined or not exported. All right. So local testing. Let's see what's wrong with my index. Not defined or index delete index.js. So it's requiring this. It's all good. This seems pretty much okay. Package JSON is fine. Index.js. Okay. Hello, hello. Let's see. So I'm actually comparing working code with the one I typed here. So template src node.js 12x, that all fine. Index put, index put, index get. Did I do it correctly? Index get. Get function index.get src, that looks all fine. Policies. Yeah, those looks pretty fine. If I go to, let me actually do something here. If I go to AWS SAM and build and go to get function, if I vim, oh, I didn't export my get function. Why? Why didn't you export my get function? You should have built my export function. Get function index.get. Exports.get. It should have exported this. Did I paste something wrong? There's a get. There is a delete. In essence, I've literally just copy pasted my code here. So the only thing that I've not copy pasted is the template. So this is where the problem must exist. So index get is the handler runtime Node.js 12x. Code URL is src. That's fine. Then policies. This seems fine. Serverless function. Okay. Oh. Sound build. And use 12. Building function, get function. That's all fine. Building function, put function. That looks all fine. If I would be doing ll sam build and the get function. Okay, seems okay now. I do have this get function. I didn't change a thing. Sometimes the SAM rebuild just helps. Okay. Okay. Yeah, every time you make a change, you need to run a SAM build again, so you can do it once more. So excellent. Let's see if this works. Actually, zoom in this window and open up Postman again and request this. And what we'll see here, you will see that invoking get index get, it's running it inside of a Lambda container. And okay, we have something. So it says info get item failed for doc undefined. So it's unable. It was not able to get this resource because that resource does not exist, which is pretty cool. We have moved on somewhere. So we were able to actually emulate this. Okay, so let's actually create something. So let's create Darko. I'm gonna use the put request, and I'm gonna go here to body. I'm gonna do xform URL encoded. I'm gonna say name is Darko. Location is Berlin. Age is 32, and because that's fine. Oh no, you know my age now. And click send. Let's see if this works. Sending request. If we see here, it's launching another little container here to a Lambda function. It says put item failed for doc name Darko location Berlin with error resource not found exception. Resource not found. What could that be? Requested resource not found. Actually, set this. How does this look? Let's have a look at our code. This could also again be a problem with our code. So this thing here, what it does, it actually, if environment is set to AWS SAM local, so this is the environment variables we're passing. If this environment variable is set to AWS SAM local, it will use a local Dynamodb table. So it's going to be using this local endpoint. So instead of going towards the AWS table up there, it's going to be using this one. So it's going to be using Docker for Mac localhost. So this is different when you use Windows, but on Mac it's like this. This would be the address locally. So this should be fine. Actually, let's do this. Console log Dynamo. I want to see which one it's using. So if I go here and then like so, again please, SAM build. Okay. Let's invoke it again. JSON, that's all fine. Well, let's see what happens now. Wait, push this. So I get the resource not found exception again. So something is not good here. So we can see that the endpoint is actually the endpoint up in the cloud. So it's not parsing something. Okay, so I might actually screwed up with the parameters. So let me go back to here. AWS. So AWS env name is the parameter name. AWS SAM underscore local is the default one. So is it the table name? Table name, region name, and AWS env name. Region AWS env is AWS env name. This seems all fine. Okay, so let's see. Region name, node, table name. This all looks fine-ish. Let's have a look at these things. What is being passed? AWS env name. Aha. Okay. That's not the parameter. AWS env name. Is that the parameter? Table name should be. It's not good. I need to pass it. So the table name. AWS env. AWS env, is that the one? No, it's this one. So I'm actually, the JSON is passing to these parameters. So AWS env name, that looks fine. Region name looks fine. Table name looks fine. So I should be passing those things. AWS env name. Okay. Let's try it again. So without name, yeah. So it's not the one without the name should be, it's just AWS env name is this one. So these are the parameters I'm passing to SAM, right? And these ones are actually the ones that are being passed on to the, oh, see, that's their point. No, it should actually reference these. No, it should reference these. Yeah, because it's referencing the ones that are being passed on. Okay. You know what? You might be correct. You might be correct, sir. So AWS env like so, and then region like so, and then table like so. Just try with the get one, or actually no, do it all. Table name, region. Okay. Excellent. SAM build. It's much better like this than doing it on the cloud and having to attempt all this all the time. And then SAM local start API like so. Fingers crossed. Send. Okay, that's, yep, you were correct. We got an empty body now, so we were able to put things. So if we look at the here, info item put succeeded, and we can see that the endpoint is correct now. So thank you, Bokyo. You corrected me. So we can see here that the host name is basically local, and it's passing all the things to a local Dynamodb table. So if I go back and do the get request now with just this, I can do this because it's looking at this little value here. It should return to me some information here. Excellent. So it returns name, dark location, Berlin, age 32. Excellent. So we can see it here once again that it has been successful in doing this. Excellent. Perfect. So now let's actually try to run the delete one just to make sure it works. It works. Looking at the logs. This application could have been a bit better by actually returning proper information back, but yeah, deleted item successfully with ID Darko. Perfect. Excellent. So now, once we are satisfied with this, we can again do. I'll just run a build again, just to be sure. SAM build, but I don't have to do this. I just like to. Now, once we are successfully, once we're happy with our application, what we can do here is actually, let me zoom in. We can do SAM deploy guided. So this will actually deploy this application to AWS directly from your workstation. So we'll give it a name called streaming CRUD serverless, right? Serverless. Excellent. EU West 1. This is the region. Confirm changes. Yeah, that's fine. Why didn't it ask me for parameters? Interesting. Wait. It should have asked me for parameters. Buddy, why no parameters? The parameters? Okay. Interesting. Okay. streaming run SAM US 1 big boy, yeah. Parameter overrides. Why didn't it take my parameters? So I'm sure that this will fail because it didn't take any parameters from me, and it should. So let me just have a look here. It's failed. So enable, okay. Parameters. Typo. Parameters. Build, please. Okay. And deploy. Guided. This is fine. US one. See, it asked me. I'm gonna use resource table here. That's fine. US one. That's fine. This is something I'm gonna change. AWS env name will not be SAM local. It's gonna be prod. Confirm changes. Excellent. Allows CLI IAM role creation. Absolutely, you're allowed. May not have authorization. It has. It has. Save arguments to a toml file. Let's combine multiple markup languages. Why not? Okay, so now it's going to create a change set for CloudFormation. So in essence, it again runs CloudFormation. So that's all fine. So it's going to add all of these things. So it's going to add a couple of functions, a couple of permissions. It's going to create a table and say, yeah, that. And this should be fine. While this is happening, let me move into this. Find CloudFormation. We can see that Steam CRUD SAM is in progress. Again, the same thing. We will see that we will have a bunch of things being created, from functions to permissions to tables, and then API gateways, of course. That is fine. Okay, it has been completed. So going back to here, we will see excellent. The CloudFormation output has been completed, and this is the output. So see, this is my typo again. But do this and go open up this. And actually, no. Let's open up Postman. Again, do resources and Darko. Let me run a get against this, and item not found. So it's a bit faster because it doesn't have to spin up a container for me locally for me to do this. So if I do posts and body and form quoted data, so name, Darko, location Berlin, age 32, and run send. It's not post, it's put. And once again, excellent. Nothing came back. So doing a get request, I can do this and 403. We can't connect to the server website. This might be such traffic. What? Really? CloudFront. That is weird. Resources Darko. Change work. Really? I get a 403 for a get? Huh? Yeah, okay. I just posted some data. That might be a problem. But yeah, so here's I get my information back, all that good stuff. If I run the delete one, fine, and excellent. So we have our application running in the cloud without a problem. Now let me actually just do a quick fix to my stack here. So let me just do so save like that. SAM build. And if I just do SAM deploy, I think I don't have to use guided anymore. SAM deploy. That, yeah, it will deploy. It will take all the save settings I have in the toml file, and it's gonna just do all of those things. So it's gonna make a change set again. Yep, deploy this change. The change is minimal. It's just gonna basically change my output. So that's it. Cool. So this has been really nice. I think it's a very neat way to work with serverless applications by using SAM. It gives you this really nice template modification on top of CloudFormation, so it makes it easier to write. But it also gives you this amazing testing utility, SAM CLI local, that you can run those tests locally without having to basically attempt them on the cloud. So this is a real cool thing. And if you have you seen my stream last time, well, a few weeks, months back actually, I did a stream on Cloud9, and it basically Cloud9 gives you the ability to locally test all of these things, and it uses SAM. So that is pretty cool. So yeah. You can also package your application to put them on a special S3 location, and then you can, from there, you can have that application being deployed. So if you would be using something like CI/CD pipeline, you would, instead of deploying your application through the CLI, you would package your SAM application on an S3 bucket, and then use the next step in the pipeline as a CloudFormation step to actually deploy this serverless application. So pretty cool, pretty neat. I definitely will be playing around with this a bit more. So yeah, well, thank you very much. This has been a quick look into AWS SAM. So we have created the application from scratch, a simple serverless CRUD application using SAM. So we have tested it locally. We have run a bunch of tests. We have actually emulated Dynamodb locally on my workstation, and we have once successfully deployed this application to the cloud using the SAM CLI. So my name has been Darko Mesaros. I will be seeing you next week on a Tuesday. Yeah. So I hope you have a really nice weekend, and well, the rest of the day. Bye bye.